Hello, and welcome to our 12th lecture on Java Programming for Beginners. In today's lecture, we're going to spend time talking about one very important feature of the Java programming language, and that is the arrays, Java arrays. So to get started, let's begin by defining what an array is. I have a definition on the screen here. It says an array is a contiguous memory location of fixed length that can hold elements of a particular data type. Now, looking at that definition, there are a few keywords we should take into consideration. The first one is contiguous. We say an array is a contiguous memory location, which means the different locations in memory must be next to each other. The next one there being of fixed length, which means once you create an array, you cannot change the size. We're going to see all of that in action as we go into the details. And the last thing I want you to note there on that definition is the fact that it can hold elements of a particular data type, which means you can declare an array to be of a particular data type, for example, int, character, float. And once declared of a particular data type, once declared to be of a particular data type, it can only hold elements of that data type. You cannot get an array and put maybe an integer inside and later on you add a float inside the array and so on. That does not work. That might work in a language like PHP and in some other programming languages, but when it comes to Java, remember, I always insist on the fact that Java is a strongly typed programming language, which means you must respect the different data types. We're going to see that in action, but to better understand arrays, I want us to get a scenario. Arrays are not very different from normal variables, but to explain that, I'd like to do it with an example. Let's say we want to store variables, right? We know how we declare variables. We want to store some values. So I declare here, I say int x is equal to 3. What happens is 3 is kept in some memory location there and I can access it using the variable x. I say float y 2.5 and the value is kept in some memory location here and I can access it using y. Same thing with int k is equal to 4. I have some integer located in some memory. Look at this one is kept here, this one is kept in some other far location, anywhere in memory. You can see 2.5 here, you can see 4 somewhere far in memory. They are not related to each other, so they can be kept anywhere that the compiler designates for that variable. Now, if we come down here, I do something else. Now let's take, for example, I wanted to store the scores of 5 students. Maybe I gave a test and 5 students in my class took the test and I want to keep their scores in my program. Now you see that I have to declare 5 variables, score 1, score 2, score 3, score 4 and score 5 just to store the result of these students. 5 students is not a big problem. So I can comfortably create 5 variables and I call them score 1, score 2, whatever, right up till a maximum number, and I store the results inside them. But let's take a situation excuse me. Let's take a situation where you have, let's say, 100 students or 1,000 students and you need to store the result of all of these 1,000 students. Are you going to create 1,000 variables? Are you going to create 100 variables? Are you going to create 500 variables? You realize that if you have to do that, your programming becomes very difficult and probably you will give up before you start if you have to spend time declaring 1,000 variables in your program before doing some actual work. You will realize that your coding life will certainly be so miserable. So to solve that, we could bring in the concept of arrays, and that will help us. One way to look at an array is like a container that holds many items of the same type. Like we could say a container with small spaces that can fit, for example, that data can fit into those different spaces. For example, I have a memory slot here. Let's say it is an array and it has different compartments of the same size, because arrays must be declared of a particular data type. So it provides compartments for us to keep in our data. And like we said in our previous in the previous slide, we mentioned the fact that array, we said an array, if we go back to the definition, you see an array is a contiguous memory location. So for example, what I want to do here is I want to use this variable score. So I want to declare one variable and let it point to all my results. You see here I have one variable score and it's pointing to all of my results. We're going to see that how we do that shortly, but this is what I have down here. This is my memory location. You can see the memory block, and then you have some values inside: 10, 17, 18, 11, and 12. Those are the values. Now I can use this variable score to point to all of these values. And how do I do that? First of all, I declare a variable score that can hold 5 integers. For example, in this case, let's say we just have the score that points to all of these. We're going to do the declaration later. But to access the first element in that container, which is our array, I use scores, which is the name of the variable that points to all of these. I say scores and I put in square brackets 0. This is the first value. The first value is always at position 0. Now, array indexes, these positions, the different positions of these where you can fit these numbers in the array are what we refer to as indexes. The different array indexes can be used to access the different values. And array indexes always start from 0 to 1 to 1 less than the length of the array. So if we have an array here, we have this container that can hold 5 elements. We have the elements the indexes always start from 0. So we say 0, 1, 2, 3, 4. The first item is in position 0. The second item is in position 1. The third position 2. The fourth position 3. And the fifth position 4. So you see that the array indexes will always be 1 less than the total length of the array. The array can hold 5 elements. Since the indexes start from 0, we have indexes 0 right up to 4, which gives us a total of 5 different indexes. And like I said before, to access items in an array, we use the name of the array and the position of the item, in this case the index, and we put it in square brackets like this. So when we do this, scores open square bracket 0 close square bracket is equal to 10. We are putting 10 into the first position of this array, which is index 0. We are putting 17 into the second position of this array when we do this down here, which is 17. We are putting 18 into position 3, which is index 2. We are putting 11 into position 4, which is index 3, and we are putting 12 into position 5, which has an index of 4. What I want you to have in mind is that the indexes always start from 0, not from 1. If you start from 1, you're going to miss the first item in the array. We're going to talk about these in details, but since we know what the structure is, let's go ahead and see how we can declare an array. But remember, we said it occupies a contiguous location in memory. Like you see here, there's no space. Like the first item is here, the next memory slot has something the next. There's no empty memory slots between them. All the items in the array are together in a contiguous memory location. You should also take good note of that. So with that said, let's see how we actually declare an array. Alright, on my screen here, array declaration and instantiation. To declare an array, like we said, the definition says arrays must be of a particular data type. Remember that? So we declare an array like a normal variable, int scores. So we are declaring an int variable name called scores. But the only difference between a normal variable and array is the fact that we add this set of square brackets right here immediately after int, the int data type. We could declare arrays to be of any data type. Down here I have byte, the square brackets, to specify the fact that it is an array, and the name of the array, which should be any valid identifier. So I say byte array, and the name of my array is an array of bytes. So byte square bracket array of bytes. Here I'm declaring an array that can only hold bytes. Here I'm declaring an array that can only hold longs. Here I'm declaring an array that is capable of holding doubles. Here I'm declaring an array capable of holding characters. Okay, and it continues. I'm declaring an array here capable of holding strings. And we're going to see later you can also declare arrays of objects, different kinds of objects. String is an example of that. And we'll see how to declare arrays of some other objects that we will create along the line. But what I want you to know is the fact that you declare an array like any normal variable, except for the fact that you must add these square brackets. There's nothing inside the brackets and there's no space between the square brackets. You must add it there to specify that it is an array and not just a simple variable. Now there are two ways to declare an array. This syntax here is the one you commonly find, which is the convention that the square brackets should always follow the data type, because the data type is int and the square bracket specifying that it's an array. But you can see to the right here I have int scores, and then I have the brackets after the name of the array variable. That is still fine. This was actually introduced in Java because that's how it is declared, or it was declared in other programming languages like C and C++, and maybe it was meant for accommodating developers who came from those other programming languages. But the convention is for you to use this one with the square brackets that follow immediately after the data type, because it is the data type and these square brackets that determine the type of the array. The data type of the array is made up of int, the data type, and then the square brackets to specify that it's an array. And if you choose to go with this, it's fine, but like I said, it's good to follow convention. So I usually go with the one where the brackets follow the data type immediately. If you do the other one, it's still going to work, no problem. Now, when you declare an array, nothing actually happens. You're simply just telling the compiler that somewhere around along my program execution, I'm going to need an array type variable to be able to store some data. But no data has been created in memory, and the array itself has not been created in memory yet. Now, to create the array in memory, you must instantiate it. And one way of instantiating an array is by using the new keyword. Same like we instantiate normal objects, you actually see that arrays are objects. So same like we instantiate other objects, you have to use the new keyword, and then you use the data type of the array. See here, I'm declaring an array of type int, and I'm calling it scores, and then I'm instantiating it using the new keyword, and I say int. Then I pass the length of the array. Remember, our definition said arrays must be of a fixed length. They have a fixed length, they cannot change. So when instantiating the array, you must specify the number of items you want to store inside the array. And in this case, I'm saying that I want to be able to store 3 integers inside the array that I declared here, the array scores that I declared up here. That's what I'm doing. I say new int, and inside this square brackets I put 3. You could still do all of this in the same line by saying int square bracket scores is equal to new int 3, and it's going to work fine. Same thing the way we could initialize and we could declare and initialize a normal variable on the same line. So we can declare and instantiate an array on the same line as well. Now, if you don't want to use the new keyword, there's another way you can instantiate your array like this. You declare it and you instantiate it on the same line. But if you're using this syntax, you must do the initialization on the same line. If you first of all declare it and you come down and you try to assign an array to the variable that was declared like this, it will not work. I'll show you that again in action. When you do this, you see here I'm declaring and initializing at the same time. I cannot declare. If I want to use this syntax here by passing the values directly in the curly braces, I cannot go ahead and do that on a different line. I must do it on the same line as the declaration. But on the other hand, if I want to use the new keyword to instantiate the array, then I can declare it on a different line. Now, once my array has been declared and initialized, I can now put in items inside. So like we said earlier, you use the name of the array and you use the index position. And remember, array indexes always start from 0. So down here, I say scores, I open a square bracket, 0 is equal to 100. What I'm doing is I'm putting the value 100 into the first position of the array. I go down here, I say scores 1 equal to 200. I'm putting the value 200 into index 1, which is the second position in the array. And I go down here, I say scores, sorry, this is lowercase, not capital. I say scores, bracket 2, I close the bracket, equal 300. What is happening is I'm putting the value 300 into the third position of the array, which is index 3. Now, I initially declared my array to be able to hold 3 integers, which means I only have 3 index positions from 0 to 3. If I come here where I have the note here, you see I'm saying scores position 3 is equal to 100. If you do this, it will not compile this portion of your code. If I do this in my program will not compile because my array can only hold 3 elements. And if the indexes start from 0, it means I only have index 0, 1, and 2. There is no index 3. If I have an index 3, it means my array is holding 4 elements. But like we said, arrays have a fixed length, and once it is declared, the size cannot change. So I cannot put anything into position 3 because my array declared up here only has 3 positions from 0 to 2. 3 indexes from index 0 to index 2. There is no index 3. If I had an index 3, it means I have 4 elements. And since the array cannot increase in size, when I try to put something in position 3 does not exist. So it's going to fail. I'm going to show you that in action shortly. So with that introduction, let's go down and actually write some code and do some work with arrays to see exactly how they work. All right, I'm going to bring up my NetBeans here. All right, so I have my NetBeans ready. And what I'll do is, first of all, you notice I've cleared out everything I had before. So I'll just write a new method, public void array demo. And I'll put in the parentheses and put the curly braces to define the body of my method. And inside here, I'm going to declare an array int scores. First of all, I'll make it a normal variable and I'll put it inside there. That's how we declare a normal variable. Now to convert it into an array, remember, you just have to put square brackets immediately after the return type, after the data type of the variable. But now you have an error. Why? Because you don't just store values inside an array, but you store values inside the different indexes of the array, not inside the array variable itself. Once you declare an array and you initialize it, it has indexes, and that's where we have to store our values. So I'll take this off, and like any normal variable, when you declare a variable, you're simply telling the compiler that I'm going to need space to keep something inside, but you have not yet put anything inside. The same thing holds true for arrays. Once you declare an array variable, all you're saying is, hey, compiler, somewhere along the line when my program is executing, I'm going to need space to store some integers. I'm not telling the compiler yet how many integers I'll be storing inside there. All I'm telling the compiler is I'll store some integers, so get ready. When I tell you to store a particular number of integers, go there and now define the space. Now the next thing after declaring the variable, the array variable here of type integer called scores, the next thing I have to do is to initialize it. And how do I do that? I say scores is equal to new int, and I say 3. Remember, we create objects using the new keyword, and that's how we initialize arrays as well. You see, arrays are actually objects, and we would see that as we go along. So what I'm telling the compiler here is, this first statement on line 26 says, hey, compiler, somewhere along the line, I'm going to need space to store some integers. Then down here on line 27, I say, hey, compiler, remember I said I'll be needing some space to store integers? Yeah. Now go to that space, make sure the space that you reserve for me is capable of holding 3 integers. Just 3, nothing more, nothing less. Well, you could put less and leave some spaces empty, but it would never hold anything more than that. And once it is initialized, I can now put in values inside there. So I could start by saying scores 0 is equal to 100. Scores 1 is equal to 200. And scores 2 is equal to 300. All right. And I'm going to print that out here, and then I'll explain it to you. System.out.println scores 0 is plus scores 0, so that we print out the value that's inside there. And I'm going to do the same thing for the next 2 index positions, the next 2 elements of the array. So I'll say scores 1 is equal to scores 1 and scores 2, and that. Now let's run this and see what we get, then I'll explain to you exactly what is happening. Okay, I have not called it yet, so I say new Java tutorials dot array demo. Good. You see, what do we have? Yeah, remember, array indexes start from 0. So we have declared an array of type integer, and here we are instantiating it, and we are saying that array should hold 3 integers. That array is capable of holding 3 integers. And down here on line 29, we say, hey, go into the array that you created for me, and in position index 0, position 0, put the value 100. In position 1, put the value 200. In position 2, put the value 300. That's exactly what we are doing here. And if you come down here, you see the output. When we print it, you see that position 0 is 100. We're printing the value inside position 0, and you see it gives us 100. The value inside position 1 gives us 200, which is what we assigned here on line 30. And same thing for the value at position 2, which was assigned on line 31. It gives us 300. Now you cannot do this. I cannot say scores 3 is equal to maybe 500. This, you're not seeing any error, but once you run this program, it's going to throw a runtime exception. We're going to talk about exceptions later on, but this is actually what you see as a runtime error, or we refer to it in Java as runtime exceptions. It's an array. It's capable of holding anything. So at compile time, you don't know, the compiler does not know how many things you're going to put inside there. It's possible to have more things inside the array. But later on, when your program starts running, it will try to access index position 3. Remember, array indexes start from 0 to 1 less than the length of the array. In this case, our array is 3, so 3 minus 1 is 2. So the indexes will start from 0 right up to 2. When I run this program, it's going to run fine until when it gets to this point, then we're going to see an array index out of bound exception. And our program will fail because there is no index 3 of our array. So let's run this. And now you see exception in thread main, java.lang.array index out of bound exception. You want to be careful with that on line 32. That's what it's telling me here. So don't do that. Array indexes are always 1 less than the length of the array because they start from 0. So you cannot do that. Now, if I don't initialize the arrays, I'm going to comment this out. And then I'm going to run it. And you see everything is 0. Once you create an array of a particular data type, all the index position have the default values for the data type of which the array is created. In this case, the default value for integers is 0. If I change this to a float, then we expect to see 0.0. And I initialize it as something capable of storing floats. Now, if I run it, we expect to see it having default values of 0.0. So have that in mind as well. Alright, now that we are clear on that, there's no doubt, instead of accessing, like we said before, instead of declaring 1000 variables, we want to use an array. But if you declared an array with 1000 positions and then you go ahead initializing the different positions one by one as we have done here, it's not going to be of any help. I guess so. So what we do is, you want to use maybe a loop to initialize the different components that make up the array. So I'm going to do that here. I would say maybe, okay, I'll declare my array still. I'll put my array there. I'll just take off all of this manual work that I did here. And I'll declare my array to be capable of holding 100 items. And then I'll use a for loop to initialize the array. So I'll say for int x is equal to 0. Why? I'm using 0 because array indexes start from 0. And then I'll say x is less than or equal to, is less than 100. Now, instead of typing 100 there, that's going to work fine. X++. It's going to work just fine. But instead of typing 100 there, I want to show you one very good property that all arrays have. All arrays have a length property that when used on an array, returns the length of the array. So I could say, if x is less than scores dot length, just before we run that, I'm going to comment this and actually show you that if I say system.out.println and I say scores.length, and I'll just put a message here, the length of scores, is, you'd see it should print 100 to tell me that scores has 100 items. If I change these to 20, I should print scores has 200. Now I have 200. If I change this to 233 and I print it again, you see that it prints length is 233. So all arrays have a length property that could be used to get the total number of items in the array. So since we already know that, I'm not going to use 100 here. I'm going to use the length property. So I'm going to say int x is equal to 0, and if x, as long as x is less than the length of the array, keep on looping. And then I would say scores x, which is the current position. Since indexes start from 0, I'm using the first index, and go into the first index and you put the value x plus 1. What am I doing? I know that array indexes start from 0, so I declare my variable x to start from 0 because I want to use that for the indexes. Now, we said array indexes start from 0 right up to 1 minus the length of the array. So since I have 100 items in this array, let me put it back to 100. Since I have 100 items in this array, it means the last index should be 99, starting from 0. So that's why I want it to be less than. I don't want it to be less than equal to the length of the array, because if I put that, then I'll have index position 100, and my array indexes start from 0 right up to 99. So I take off that and I leave it as less than, so that when it gets to 99, it no longer gets into the loop. But since I want to count from 1 to 100, every time I'm at a particular index, I add 1 to it to get the current value. So if I add 1 to 0, I'll get the first item in my array, which is 1. When I'm at 99, I'll add 1 to get the last value, which is 100. And that's how my array is initialized. And later on, I can use another loop. These variables are in different scopes, but I'll just take them out. I'll change it when we talk about scopes later on. We can keep playing with them like that. So I'll just name it I. So I'll say system.out.println, and I'll say I'll say scores plus the value of x, or I, sorry. I just want to print that so that we see what's in every index position. I need to put a plus here. Remember, I talked about the concatenation operator. I'm simply just concatenating the current index position to this string and this string to make it look like what we are familiar with is equal to, and I'll add the last value here, which is the current value of scores, current index position. And if I run this will initialize, and this second loop here will just print out the values of that array. So if I run this, now we have our array printed out here. Let me pull this up a little. You see, index position 0 has 1 right up to, it continues like that right up to 100. So now you see that you can use different constructs to put in variables and play with your arrays, and it's easy to work with multiple values instead of declaring individual variables. Now if we wanted to declare an array that could hold 1000 things, we could put that and let the program loop through it and do whatever we want. Maybe we want to go through the results and calculate averages of students. We don't need to put them out one after the other and declare variables to hold each and every one. That makes our life pretty simple. Alright, since we know how arrays work, there's one other thing I want us to talk about. We've seen the length property. Now let's talk about passing arrays to and from methods. Oh, before that, let's talk about some few methods that arrays have. I'm going to comment this out. I'm going to take all of this out. I don't need it anymore. And the next thing I want to show you, okay, there was one syntax for instantiating an array that I've not shown you yet. So I could say int scores is equal to, I put parentheses, the curly braces there, and I pass in my values directly. I could say 4, 5, well, 34, you could put in it as long as they are integers. Look at, I cannot put a float there or a double because that array can only hold integers. So once I put 9.0, that's a double, or 9, that's a float, so it would not work. I must only put integers in my array, like that. That's another way you could declare an array, and you could go ahead and do the same thing for int x is equal to 0, x is less than scores dot length x plus plus, and I could come down here. I say system dot out dot print ln, and I say scores x is equal to scores x. And if I run that, it should print me the different indexes. Index position 0 is, let me screw this up, screw this down a little. You see, index position 0 has the value 34, position 1 has the value 5, position 2, the value 3, and so on. Index 2, sorry, not position, the index 2, the position is 3, but the index is 2, and it continues. So it's basically the same thing as we did before, except that this one is just some manual work. But remember, like I said before, if you're doing this, then you must declare and initialize the array on the same line. For example, if I declare the array here and I try to do this, I'll get an error. I cannot do this. You cannot do this. Once you use this syntax, you must initialize and declare the array on the same line, in the same statement. Let's be more precise. In the same statement. That's what happens. Okay, now that we have done that, I'm going to add a few items in this array, and let's see a few methods that arrays provide for us. I'll take this out. No, okay, no, I need it. Well, I'll write it again. There are a few methods that arrays provide for us. You have, well, these methods are actually found in the arrays class. There is a class called arrays. It's written as arrays. And this class provides us several methods that we can use to manipulate arrays. The first one is sort. For example, I have this array here. The array is in total disorder, right? It's not sorted. But I could decide to sort this array maybe in ascending order. Normally when you use sort, it's going to sort it in the natural order. And what I'll do is I'll simply pass this array to the sort method of the arrays class, and it's going to return a sorted array. So what I'll do is I'll declare another array here, int sorted values, or sorted array is equal to arrays dot, oh sorry, I don't need to declare any variable. It's an array and they are references, so I don't need to do any declaration because it's not going to return anything. We're going to see later on that arrays are objects, and once you work on it, you're working directly on that memory location. So I'll say arrays dot sort. I call the sort method. If you see the help that NetBeans gives me, you can sort an array. It's an overloaded method. We're going to talk about overloading later on after we start talking about inheritance. When we talk about object-oriented principles, actually not inheritance. When we talk about that, we'll talk about method overloading and some other stuff. But what I want you to see here, this will actually be when we're talking about polymorphism, not inheritance. So you have an overloaded version a method that can sort longs, a method that can sort bytes, a method that can sort characters, floats, whatever you choose to sort. And we're going to be using the one that can sort integers. We're going to use the one that can sort ints. And what happens is, it's going to take this array. First of all, I'll print this array before I sort it. For x, int x, I'm using the enhanced for loop here. Int x in scores, then system.out.print, and I'll print out scores, the value of x plus some small space there to make it more presentable. Then after that, I'm going to print some empty space, .out.print line. I'm going to break it to a new line, and then I'll sort the array and I'll print it again. I'll first of all print the message, system.out.print line. Sorted array, and down here I'll look through the array again and I'll print its values out so that we see what's happening. For, I could use the same variable, I'll change this to y so that we're not mixed up. We'll talk about that later on. But if I use x, it's not going to worry me because they have different scopes. So let me run this and let's see what we have as the output. Here we have the original array which is unsorted. You see it's 5, 78, 1, 5, 6 and so on. Now after we call the sort method on the array, we now loop through the array again, and now you see it's printing the values in ascending order. So you could use the sort method to sort your array in ascending order. It uses the natural order of numbering to sort the array from the smallest to the largest. Now there's another method as well that you could use on arrays, and it's the binary search method. I'll take this out again and I'll say arrays dot binary search. Let's use the one that takes in integers. Now one very good feature of this IDEs is that when you use that, you're going to get some documentation. Unfortunately, I don't have documentation downloaded and installed on this one, but it would have given you a hint on what this method does. But what happens here is, when I use the binary sort method on an array, it takes in the array and the value you are looking for. So if I put in the value 5, for example, it's going to return the index of the first occurrence of the array. But one restriction about this method is that before you call binary search on an array, the array must first of all be sorted. So when I say sort, I'll put the old values that I had before. I'm going to need them so that we see that. I'll take this one off. I don't need this. I'll take this off. I don't need it. First of all, I sort the array so that the values occur in ascending order. Then I print it out so that we will actually see it before we continue. Then I say maybe print a blank line. System.out print ln. And then I'm going to call the binary search, system.out.print arrays dot binary search, and I want the one that gets integers. It searches an array of integers, and I'll pass in 5. Then I'll run this. I'll run this and let's see what we get. You see, this is my array up here, sorted array, and then down here I have 2. Like I said, it prints the first position, the index of the first occurrence of the integer that was passed in. Right? Are you seeing? Good. Now let's pass in, to confirm that, let's pass in something else that's in the array. and I'll run it again, and now it prints 8. Let's look at the value 89, the first occurrence of 89. We're looking for the value 89 inside the array scores. 0, 1, 2, 3, 4, 5, 6, 7, 8. The first occurrence of 89 is at index 8, and that's why we have it here. If we pass in 100, you see, position 10, index number 10. This array has a total of 12 elements. Index number 10 has the value 100, and that's what's printed out. Now let's pass in something that is not. Alright, now what's going to happen if we insert a value, if we search for a value that's not found in the array? What will happen is it's going to return negative the length of the array, and we have minus 12 there. Our array has a length of system.out, .println, and I'll say scores.length, and if I run that, yeah, our array has a length of 12, so it returns negative the length of the array. And that's what we get when we use the binary search method. Now another method that you would find in the array class that will be helpful is the equals method. The equals method in the arrays class. You want to be very careful with this one. It's going to throw you off a lot. Now let me declare two arrays here. Int first array is equal to 1, 2, 3. Int second array is equal to 1, 2, 3. Int third array is equal to 2, 1, 3, and int fourth array is equal to 3, 2, 3, 5, for example. And I'm going to save that. I'm going to save this. And now let's look at the first and the second array. They all contain the same values, 1, 2, 3, right? Now I'll say if first array is equal to second array, then I would say system.out.println they are equal, and then I would say else, which means if they are not equal, then you do this system.out.println they are not equal. Take a guess and let's see if you got it right. Alright, I'll run it and let's see if you were right. They are not equal. These arrays contain exactly the same thing, but they are not equal. Array 1, 2, 3 and the second array 1, 2, 3 are not equal. That's very correct. They are not equal. We'll see that we are not comparing those values actually. Let me do this one first. Third array, they are still not equal. And then the last one, fourth array, they are still not equal. Now be very careful when you use these. Arrays are what we call reference variables. and like I said, we'll talk about them later on. But these arrays don't actually hold these values. They hold a memory location where these values are kept, and this array is different from this one, so they are kept in different memory locations. So when you use the equals comparison operator, which is two equal signs put together, you're actually not comparing these values inside here. Instead, you're comparing the addresses, and these arrays were declared and initialized differently, so they have different addresses in memory. Just before we go further, if I set this is equal to first array, now if I print this, I should see they are equal, because here I have passed the address, this memory location, to this one, to fourth array, and that's why they are equal. But as long as I'm doing a different declaration here and initialization here, they will never be equal. When you use this equal sign, you're comparing memory addresses, you're not comparing the actual values. So to compare the actual values, the arrays class provides us a method that we can use, and that method is the equals method. So I'll say arrays dot equals, and I'll pass in first array and second array, and I'll run this again, and now I should get they are equal, because they both contain the same values. So when you want to compare arrays, to compare the actual values in the arrays, you use the equals method of the arrays class. Don't use the equals in objects. Those are two different things. Don't use that one. Use the one that you have in the arrays class. We'll talk about the equals method for objects when we talk detail about objects. But to compare the values of an array, use the equals method of the arrays class. Now, this method will only return true if the array contains the same element and the elements in the different positions match. This one is only matching because we have 1 and 1 in position in index 0, 2 and 2 in index 1, 3 and 3 in index 2. If I compare this array, for example, the first array to the third array, we would see that it will return they are not equal, because the items here 1 and 1 are not in the same position. So this should say they are not equal. But when I do it with this one here, that's it. Let me run that again so that you see the output down here. They are not equal because the positions are not the same. But if I run that again with second array, then you would see they are equal because they have the same values at the same positions. Same thing if I compare these with the fourth array, I should see that they are not equal because the values themselves are different. So what I want you to note there is the fact that the equals method of the arrays class will only return true if the arrays contain the same values in exactly the same position. And with that said, there's another method. You can go ahead and Google and experiment. You're going to see, for example, the fill method, and you can find out what it does. The best way to learn this thing is to do research. I can't list. You can never find a class where all the programming concepts are going to be taught to you. Everything is going to be taught to you. The libraries are just too many, so you have to do some digging. So I would advise you go back and investigate more what you can do with arrays. But before we wrap up this video, I want to talk about one last thing. Like normal variables, we can also pass arrays to methods, and we can return arrays from methods. So what I'm going to do here is I'm going to pass an array into this method, and I'll declare my array here int scores is equal to, I'll just create some values here, 4, 5, 3, 10, 40, 100, 11, 45, whatever. That's the array I have created. And what I want to do is I want to pass the array into this method. But to pass the array into the method, like we pass variables into the method, we must first declare the method to be able to be capable of accepting the variable. In this case, we must declare our method to accept an array. So since my method should accept an array of integers, what I'll do is I'll say int and same way like you declare numbers. And what I'm saying here is this method is capable of accepting an array of integers, and I'm going to call the array numbers. And inside here I could do for numbers, for num, for int num in numbers, print out every value, system.out.print num, and why is this thing hanging here? Take that off, and then I'll call my method and pass in the array. So I'll say new Java tutorials dot array demo, and I'll pass in scores. And when I run this, you see that it passed the array into this method, and this method did the looping. Remember, it's an array, so it must have the square brackets after the data type. Yeah, so if I take this off, you realize that this method takes in an integer and not an array. And if I change this to a float, I should have an error as well, because I'm supposed to pass in an array of numbers, of integers, not an array of float. This method is expecting integers, and I'm passing a float, so you want to be careful with that as well. Now, with that said, like we can pass methods into arrays, we can also we can pass arrays into methods. We can also return arrays from methods. The first thing I'm going to do is I'm going to print out some message here, system.out.print line, printing unsorted array in array demo. And then what I'll do here is I will sort the array. So my main method will pass in an unsorted array. This method will print out the unsorted value. Then it would sort the array and return it back to the main method. So I'll say arrays.sort, and I'll pass in numbers, and then I would return numbers. And like everything, void means it returns nothing, so I must specify that I want to return an array. And then here what I'll do is I would declare another variable, int sorted array. I'll declare another array here, sorted array, and I'll loop through it. I'll loop through it up here and print out the sorted values, so we actually see that. So I'll say, don't mind my indentation. So I would say for each sorted array, for each number in sorted array, print out the value. And when I run this, all right, I wanted the print line method somewhere to break this off. Okay, I should put it down here just before I return. System.out.println and some blank line, so that it breaks it down to a new line. System.out All right, I run that again, and you see here, printing unsorted array. You see that this one passed in, main passed in the unsorted array on this line here, on this line 24. Main called the array demo and passed in the unsorted array. Array demo printed the array, then sorted the array here on line 28, on line 38, and then returned the array to main method, and then the main method printed out the sorted array. That's why we have the second print here, the second output here, sorted. So you see that you can pass arrays to methods and you can return arrays from methods, but later on we'll see that this is actually not necessary, since the array variables only hold a reference and you can work with them directly from anywhere as long as the variable is visible. So you will not need to be passing them into arrays or doing what, unless maybe you're working with separate programs that need to pass things around like that. But I just want you to know that it is possible to pass arrays to and from methods like that. Now, with that said, we'll leave it at that, and in our next video we're going to talk about two-dimensional arrays.